guys, welcome back to another lesson. Today we are continuing to talk about volume. Specifically today we will be talking about pyramids and cones. So let's start with a pyramid. For a pyramid, it's once again similar to a prism. The difference when you're finding volume is that the volume of a prism is 1/3 of that of a prism that has the same base and height. Okay, it's 1/3 of it. So let's take a look at our first example here. So we have a pyramid whose base is an equilateral, triangle. So that's that shaded region right down there. So the first thing that I want to do is find the area of the base. So I've got an equilateral triangle with side lengths of 8. And I need to find the area of that. In order to find the area of that, I need to drop in a height. And when I drop in that height, it actually splits it into a 30, 60, 90 special right triangle, right? So this top angle would be 30, this base angle, or the bottom angle would be 60 degrees. And I've got my 90. I split the bottom side in half, so this would be 4. I know my hypotenuse is 8. And then this height here would be 4√3. So that is the height of the triangle. That is the base of my pyramid. So to find the area of that, I would take area of base is equal to 1/2 times the base of the full equilateral triangle is 8. And then the height of that equilateral triangle is 4√3. Okay, so if I want to find an area, I just multiply those things, 0.5 times 8 times 4. So 16√3 is the exact area of the base, and I'm not going to round until the very end. So the area of my base is 16√3, which is approximately 27.7, but I'm going to use 16√3 until I get to the very end to eliminate as much rounding as possible. So I've got my area of the base, and then the height is given to me as 21. So to determine the volume, I take 1/3 times the area of my base, which is 16√3, times the overall height of my 3D prism, which is 21. So now 1/3, oopsies. So I get for my volume 1/12√3, 1/12√3, which is my exact answer, and then I'm going to multiply that out to get a decimal approximation, which would be 190, round up to 194.0 cubic units, because I am talking about volume. All right. If you're interested, you guys can actually YouTube volume of pyramids and cones, and they'll have fun little videos that show actually, like, if you fill up a cylinder or a prism with the same base and the same height as a pyramid, they'll fill up the pyramid with water and show you kind of where this formula comes from. All right, next, cone. Very similar formula. The only difference is that my base is a circle. So it's still 1/3 area of base times the height. Since my base is a circle, 1/3 pi r squared times the height. I will have you note in this diagram right here, my h is not given to me, but by now you should be able to recognize that this is a Pythagorean triple. Okay, 6, 8, 10. So I've got my radius is 6, so good. So volume is equal to 1/3 times the area of my base is 6 squared pi, or 36 pi, times the height of my 3D object is 8. Okay, and I am just going to enter this all in to my calculator. So 1/3 times 6 squared times 8 would give me 96 pi is my exact answer. And if I want to get my decimal approximation, I would multiply that out, and it would be 301.6 cubic units. Okay, so there's the volume of the volume of a pyramid, volume of a cone, and there's one more thing that I would like to talk about, just kind of talking about ratios of cross sections. So a cross section is if you kind of took a knife and like cut through a pyramid here, right? The cross section here is parallel to my base. So the ratio is shown right here. So pause the video right now and take a minute to look at that ratio. And all of the variables are labeled in the diagram. Okay, so now you've hit play. Let's take a look at how we can actually use this. So in my diagram, I am given a pyramid and it has a cross section that's cut 3 centimeters from the base. The base area is given to me as 24 square centimeters. The overall height is given to me as 12. And then also I know that this, the 3 centimeters is kind of like the distance, right? If I draw in this right here, the distance from the base where the cross section is cut is 3 centimeters. Sweet. So now, first thing I want to do is find the area of the upper pyramid. In order to find the area of a pyramid, I need its height and I need the area of the base. Well, I could figure since the total height of the pyramid is 12 and there's 3 centimeters below the cross section, the height of that upper pyramid would be 9. Okay, so I'm going to use a different color here. So my height would be equal to 9 because that's this distance over here. And the total distance is 12. 12 minus 3 is 9. So that's what's left over. Now, I need to figure out what the area of that cross section is. Well, in order to figure out what that is, I'm going to use this ratio that I gave you above. So that like cursive C, the C with a line through it represents the area of the cross section. That over the area of the base of the pyramid is 24 is equal to K is the height of that pyramid, which would be 9. And then H is the overall height of the full pyramid, which would be 12. And I am going to square that. Okay, so now as you see, the only variable that I have left over is the area of the base of that upper pyramid. So let's just solve for this algebraically. 9 divided by 12, square that, and then multiply by 24. I get the area of that cross section is equal to 13.5 or 27/2, whichever you prefer. All right, so far so good. So we use that ratio to solve for that shaded area. Now I'm still not done because I'm looking for the area, oopsies, this should say volume. I'm looking for the volume of the upper pyramid. This should say volume down here, sorry. Just typos, always. So I'm finding the volume of the upper pyramid. I've found the area of the cross section, and now I'm going to use that to find the volume of the upper pyramid. So volume is equal to 1/3 times the area of my base is 13.5 times the height of my pyramid of the upper pyramid is 9. So I get that this volume, I'm going to label this UP, volume of the upper pyramid is equal to 40.5 cubic units. I'm in centimeters, so I will say cubic centimeters. All right, next, I want to find the volume of the frustum that is the solid figure that is below that cross section. So it's still part of the overall pyramid, but it is just that bottom portion that lies underneath the cross section. So in order to find this, there are two there are two things that I need to find. I need to find the total volume of the pyramid, and then I need to find the volume of the upper pyramid and find the difference of those two, because what's left over is going to be just that bottom portion. So I already found the volume of the upper pyramid. Sweet, good for me. Good work, Vlesson. Nice. Now I am going to find the volume of the full pyramid. So volume, I'll say FP for full pyramid. Volume is equal to 1/3 times area of the base, which is 24 square centimeters, times the height of the full pyramid is 12. Okay, so that I can enter into my calculator. 1/3 times 24 times 12 gives me 96 cubic centimeters. And now I need to find the difference of those two. So I am going to take the volume of the full pyramid, which is 96, and I'm going to subtract the volume of the upper pyramid, which is 40.5. 96 minus 40.5 is equal to 55.5 cubic centimeters. All right, folks, that is all for today. Keep up with the good work. If you have any questions, feel free to email. And also, Jack says hi. He's hungry, so I'll go feed it now. Bye, folks.